So let's start with the demo session today. So let's go into deep into what exactly Hadoop. Let's before start with, so what's the problem with the existing systems? So we do have a lot of proven softwares, well-designed database systems in the market. So even though, why do we need to go for the Hadoop? So let's start with from the problems with the existing system. So after that we'll go for the what exactly Hadoop, and then how it will be very helpful for the to provide the solutions for the real-time problems. So before start exactly the problems as well. So Hadoop is I will talk about just a couple of minutes about the what exactly Hadoop. Hadoop is a kind of distributed systems. Hadoop is a kind of distributed system. When I talk about distributed systems, network of machines are connected together so that they're a kind of master-slave architecture. So as I'm talking about, it's a distributed kind of environment. So let's compare the problems with the existing distributed environments. So first set of problems was problems with the existing distributed systems. Okay, so the main problem with the existing distributed system was, distributed system is nothing but it's a kind of network of machines are connected together with master slave kind of architecture. So master node is a node which maintains the metadata information about the data which are going to be stored on the top of the slave nodes. Slave nodes are the responsible for storing the physical amount of data which we are going to deploy into the cluster. Cluster is nothing but it's a network of machines connected together. So the main problem, the very first problem with the existing distributed system is data accessing problem. So let's draw a simple picture of the distributed environment using this paint, MS Paint. Right. So it is a kind of distributed environment. Distributed environment means network of machines connected together. Here we can call this as a master node. This is my master node. So these are all my slave nodes. So I can say like slave 1, slave 1, this is my slave 2, and then this is my slave 3. So as I said, it is a network, a distributed environment. So machines are connected together with some architecture, master slave kind of architecture. This is the traditional distributed environment. Assume like it's a 4-node traditional distributed environment. Distributed. Four-node distributed environment. Right. So when I talk about, so one is master node, the rest 3 are slave nodes. So master node responsibility is to maintain the metadata, slave node responsibility is to store the data. Say for example, I am in the need of storing the 10 GB of data. So 10 GB of data means, so we are going to submit the data into the cluster. So master node receives the data and then deploy on top of the slave nodes. So and maintain the how much GB it has been stored in each and every top of the slave nodes. So assume like here I am saving some 5 GB in slave node 1, and then I left with some 5 GB, right? So assume like I stored 3 GB here, and then rest of all 2 GB I stored in the slave node 3. So when I talk about we are good with the storing of the data. So we don't have any issues to store the data. We have good space available in the slave nodes, and then a master node can able to maintain the metadata so that I can able to store the data into the on top of the slave nodes. Now the exact problem here is retrieving the data. So why we are storing the data? For some processing. So here I start whenever I developed some application to read the data. Here is the problem with the reading of the data. The problem here is whenever we build some application and deploy onto the cluster to read the data and then or to process the data, here the problem is data axing. So entire data is reading into the master node main memory. So when it start reading the data into the main memory, obviously it causes some memory related issues or some performance related issues. So why? Because it is good to read some KBs or MBs of data, or up to max you can GBs of data, but no, Hadoop or big data is a kind of system to build for processing more than terabytes or petabytes of data. It's a system not built for processing KBs or MBs of data. So there the data axing problem comes up. So the problem here is, so we can choose traditional distributed system to process big data. So right, we have taken that one. So thing is, I have taken that one and then I stored multiple terabytes of data into the slave nodes. Now I build up an application and then start processing the data using that application. Here the problem is the application, as it is a traditional distributed system, it start reading the data into the master node main memory. So reading multiple terabytes or petabytes of data into the main memory, master node main memory, obviously it causes some data accessing problems or network related issues. So that is the problem with the traditional distributed systems if we choose to process that much of big data. The first problem is data accessing problem. So and then next problem is hardware. So whenever we are going to set up some distributed environment, we need to purchase a licensed servers or some licensed kind of hardware kind of environment to build the cluster. So it's obviously a kind of expense for the project as well as the company, the users as well. So the problem here is hardware. So whenever we are trying to build a cluster, we need to purchase licensed servers. So that is it could be some cost as well. So let's see how Hadoop will provide solution for that. Is it not that much of costly to build the Hadoop cluster? Let's see all the things while going to the discussion about the Hadoop cluster. And then third problem is data synchronization. Data synchronization. Say for example, data synchronization means whenever we are trying to access or update or doing some update for the certain records in the data which has been stored already. So some other process is trying to read the data. Obviously the reading program will get some bad data. So for that we need to provide some data synchronization. We need to build up some logic to address that problem. For that we require some complex coding. But let's see how Hadoop will provide solution for these kind of issues. As here we need to write some complex coding to make the data synchronization. So that is the problem with the one of the data. It's required more coding as well, coding skills as well. So isn't it required in the Hadoop systems? Let's see how Hadoop will provide the simple solution for this data synchronization. Is there any facility available and all those things in the next topics. So these are all the simple problems when I talking about the problems with the distributed systems. So the second kind of problems is, as I was explaining this, we have well proven databases as well. So can't we use those databases to process our big data? So let's see what if we choose some of the database system to process our big data to store our data and then to access. What are all the kind of problems it will provide? So second set of problems is problems with traditional database systems. The first problem is, whatever the database systems we have, those are unable to handle unstructured data. So what is the need of unstructured? What is meant by unstructured data? So nowadays, so we are getting data in the form of different. We are getting different kind of data. It's not restricted to we have to restrict our data to be generated in the form of only some structured format. So we have social engineering, we have some Twitters, Facebook, we have some social networking site as well. Likewise, some companies are generating site, some companies are creating the sites to understand the customer satisfaction reviews as well, and to understand what they are expecting exactly. So all those data need not to be in some structured format. So if we are trying to be our data to be our website needs to generate our data in the form of some structured environment, obviously we may lose some features as well. So that's why in these days we may not restrict our data to be generated only in the form of structured data, so that we have to accept any kind of data, but whatever the databases we have, so those are unable to handle structured data, unstructured data. So unstructured data means it is not associated with some schema as well. So whatever the logs, website logs, some Twitter comments, or some reviews received by the merchant from the customer. So those are all things need not to be in some structured environment, structured way, so that it could be generated in any way. So but we need a system to store the data and then to process the data. So can't the database systems store and process the data? No, those are not able. Whatever the database systems we have, those are built for processing or storing the structured data only. So this is one of the problems with the existing database system. The problem is these are unable to store the unstructured data. So second kind of problem is vertical scaling. Say for example, I have Oracle, some kind of traditional distributed database system, Oracle server. So my server capacity is to store multiple terabytes of data as well. But if we are storing that much of terabytes of data into the one server, so obviously when we are selecting some data out of that, it obviously gives some performance related issues as well. So further, if we are trying to that is one of the problems. So that is also one of the problems is if they are trying to retrieve the data out of multiple terabytes or petabytes of data, even though if it is structured data. So obviously Oracle, it will take some time to fetch the data out of it. So further they are developing some hexabox kind of solutions as well. So but those are all kind of costliest procedure as well. We need to invest process as well. So if I have a Oracle server, I purchased one Oracle server to store my data, right? So I have one Oracle server. It could able to store up to 10 terabytes of data. But nowadays, my data is keep on increasing day by day. So after reaching 10 terabytes of data, so if I am keep on receiving the data, so how I could handle the data in the database systems? One way is we can increase the hard disk capacity. So we can increase hard disk, so as well as RAM capacity as well. So up to how much extent we can able to increase that one, there should be some limitation as well. Why? Because it should be associated with some processor as well. So processor, cores, whatever we have attached to the server, those are all the constraints to increase the memory limits as well. So what if we are keep on receiving the data, so we cannot able to attach another server parallelly to that server to store the rest of the data. So that facility was not available in the Oracle server. So the problem is vertical scaling. Vertically, we are keep on increasing the data on the same server. Keep on increasing the memory limits on the same server. That causes, obviously that's a kind of that is nothing but it's a vertical scaling. So obviously it will be limited to some extent only. So rather than the solution for this one is horizontal scaling. So say for example, simple example is if we are if we are residing some gated community. I have constructed apartment. So apartment, its limit is up to 5 floors. So if people are keep on trying to enter into that purchasing the things, so either we can parallelly build the apartment in the next to that one. So that is horizontal scaling. If we keep on increasing the floors in the same apartment, so obviously it will collapse at certain times. So that is a kind of comparison between vertical scaling and horizontal scaling. So horizontal scaling is preferable when we are keep on increasing the data, so that without any affecting to the existing server, we can keep on loading the data into some other parallel server as well. So that facility was not available in the traditional database system. Let's see whether Hadoop will provide the kind of solution or not. So these are all the kind of problems when we are talking about if you choose some of the distributed systems, some of the traditional database systems to process our data. So these are all the kind of problems. As of I'm talking about simple problems, so those are real-time problems, so well-known problems. When we choose existing system to process, my big data. So let's see how Hadoop will provide a solution for this one. So I'm clearing this off. So as I was talking about, Hadoop is a kind of distributed environment as well, right? So Hadoop is a kind of distributed environment. So distributed environment means network of machines connected together. So similar comparison I will do here, so that you can better understanding the things as well. So let's see the differences between what are all the existing things and the traditional distributed things existing on the Hadoop systems. So this is also 4-node Hadoop cluster. Four-node Hadoop cluster. Here we can call this one as a name node. Instead of master node, here in Hadoop system it's a name node. Instead of slave nodes, here it is a data node. Data node 1, data node 2, data node 3, right? So the problem, let's open the problems. So okay, let's see the problems. The first problem is data accessing problem. So as I was explained about, the existing system will access the data into the master node main memory, but how it will be addressed in the Hadoop system. So here in Hadoop, name node is meant for maintaining the metadata. Data nodes are responsible for storing the actual physical amount of data. Here, say for example, here I am trying to store 10 terabytes of data. So similarly, here it is also storing like this 5 terabytes sorry, here is some 3 terabytes, here is it is getting stored some 2 terabytes, right. Say I have stored this 10 terabytes of data, it has been done, and then now I have built up some application, and then I am trying to process the data. I deployed that application into the name node. Name node receives that one, and then what name node it will do is, it will apply, it will parallelly execute the same logic which was there in the application. It will send that application to the data nodes. So data node means it's a kind of server. It is associated with some memory in the sense RAM as well as hard disk. So within the hard disk we store the data. RAM, we have a RAM primary memory so here we are using the local resources. So how? Because name node send the business logic to the data nodes where exactly that particular related data has been stored. Say for example, I have stored the data into all the 3 nodes. Say for example, if I did not store assume like I have stored only 5 terabytes here, and then assume like I have stored 5 terabytes here. So means here name node identifies first where exactly we have stored the data which was related for this business logic. So we have stored the data, that has been done. That's the first part. Second part is we have built up some application to process this data. So we deployed the data business logic into the Hadoop cluster. Name node receives that logic, and then it first of all it will identify where exactly we have stored the data. So here name node maintains some separate copies of files for storing the metadata information. I will explain those things when we are going for the deep discussion about the HDFS. So before that, this is just kind of overview kind of environment sessions to see how it will address the existing problems. So name node receives the business logic, and it will identify the where exactly we have stored that data which was related for this application processing, and then it parallelly assign that logic to all the data nodes. So say for example, here my data has been stored in two data nodes, and then name node identify those 2 data nodes, and then it will send the business logic to both the data nodes parallelly, and then data nodes are trying to execute that business logic at there itself without sending the data to the name node main memory. So in the earlier case, what the problem is with the data accessing problem. It is trying to read the entire data into the master node main memory, but here we are not sending any data into the master node main or name node main memory. Here we are processing the data within the data node itself, and then simply we are trying to send the results out of it. So here we are better utilizing the local resources as well. So what are all the facilities available to process the data, and then what are all the things needed to support this kind of facility, we'll see in the detailed discussion about the upcoming topics. So this is the one of the facility which using that we have addressed the data accessing problem. The second problem is hardware problem. So as I was talking about traditional distributed systems, here we need to purchase some licensed servers to build the traditional distributed environment. But here in Hadoop, we no need to go for the traditional we no need to go for some licensed kind of software or some licensed kind of servers. Here we can build our Hadoop cluster using some our CPUs itself by combining couple of multiple CPUs, and then we can make it as a server, and then using that server we can set up a Hadoop cluster as well. So even with this, even small companies also can able to maintain the Hadoop related project. So this is one of the advantages. And then third problem I was talking about using the traditional distributed system was data synchronization. There we need to we require some coding skills to we need some extra coding for the data synchronization, make it as the data as a synchronized. But here we have some interfaces, some of the packages available with respect to the Hadoop installation. So those will, there are multiple JVMs are running up and run on the cluster. Those are all responsible for make the data synchronized. So here we no need to write any extra coding to make the data synchronized. Whatever the data we have stored, so multiple JVMs are running on the cluster, so those will take care of the data synchronization. So here there is no data synchronization related issues. So only framework will take care of that things. So let's see in while going for the map reduce explanation. So I will show you how to do that one as well. So how framework will take care of that one as well. So it has been addressed all the three problems of the traditional distributed systems. Now let's coming for the problems with the traditional database systems. The first problem is whatever the database systems we have, those are unable to store or process unstructured data. But here we can able to store any kind of data, and then we have a separate ecosystems called HBase, so which is responsible for processing the complete unstructured data or semi-structured data or structured data. So in this facility we can able to address the unstructured data handling processing as well, so using that ecosystem. So we have a solution as well here. And then second problem is vertical scaling. Vertical scaling means, say for example, my cluster size is here 4 node Hadoop cluster, name node responsible for maintaining the metadata, and then 3 data nodes I have which are responsible for storing the data. So when I talking about node or slave machine, so these are all related to servers. These are all individual servers. So we are all making them into some environment by using the Hadoop software. So say for example, I have a data node, means it is a kind of server. Server means it is associated with some memory, primary memory as well as hard disk. So say for example, my data node capacity is, data node 1 capacity, it can able to store up to maximum of 10 terabytes, my server capacity, assume like. So I have 10 terabytes here. So similarly data node 2 is also similar kind of server, 10 terabytes. Here is only 5 terabytes, data node 3 capacity is. So total my cluster size is 25. It can able to store 25 terabytes of data, but my data is keep on growing. So if I receive the data more than 25 terabytes, so we have to store 10 terabytes here, some next day we'll receive some another 15 terabytes data. So with this we have filled up with the space as well. So now after next day, if we are receiving some 5 terabytes of data, so here is a problem, right? So same problem with the traditional database system as well. So what we could do, we can increase the hard disk capacity. That was the vertical scaling. But here vertical scaling is a very costly procedure. So we need to purchase the hardware, so some related information as well, so RAMs as well. So it is a costly procedure. The parallelly what we can do, how we can address this kind of problem in Hadoop is, we can parallelly attach some other server which was located in some other area, so we can simply attach this to the existing cluster itself, so that internal there are multiple JVMs are running and up and run. Those will take care of the load balancing techniques within the cluster. So cluster means it's a network of machines. So I will attach so here the advantage is we can able to add the servers or machines as and when we required. So such facility was not provided by the traditional database systems as well as traditional distributed system. This is the advantage here. See, with that Hadoop. So and most of the people are comparing with the Teradata, so Hadoop system. But the problem is Teradata can able to support there is a replication, everything will be there, can able to replicate the data, can able to synchronize the records, everything will be there. But only thing is Teradata unable to handle unstructured data, one thing, and one more thing is to build a Teradata cluster. So we need to assist with the Teradata company, so that it's a licensed kind of environment. So it's a cost-based procedure. So that's up. So this is the brief introduction about what are the problems with the existing systems and how Hadoop will address the problems which we have. So with this, we'll see how Hadoop, what are all the ecosystems of the Hadoop, and then what is the advantage, and then what are all the benefits if we start using them. So in one by one. So in this session, in the Hadoop, I'm going to teach about, these are all the topics: HDFS, second thing is MapReduce, third thing is Big, fourth is Hive, fifth is Scoop, sixth is HBase, as I was talking about, which is built for handling the unstructured data, OBIEE. So these are all the topics I will provide with some detailed explanation. So we have some advanced topics as well. So those are Kafka, Spark. I will provide you some good information on that one as well. So these are all the 10 ecosystems I'm going to cover as part of this training.